So I call this different thing. This is my tall corn plot, antique corn plot. Um, I think corn genetics are really, really neat. And so some of this old stuff, and that's what you can kind of see over my shoulder here behind me. There's some stuff here that's probably on the order of 2,000 years old or so, as far as the last time it had changed by man, whatever. We have some other stuff just a little bit farther down, maybe you can see in tassel, that very tall above the standard modern hybrid corn. That's probably about 100 years old as far as genetics goes. I look at characteristics. I mean, the stuff immediately behind me, it probably won't flower for another 2 or 3 weeks, so it's going to get tall. Just in the last few days, it popped up above the hybrid corn planted around it. But this is a material that I got from the seed genetics lab out of Illinois. Some really neat things to look at there. But it started out with a tall corn contest. The Ohio corn growers used to have a tall corn contest, the tallest stalk. And so one of the agronomists here on the farm and I, we kind of said, hey, let's get in that. And so we tried a couple varieties, found one that was pretty good. And then we've kind of since then played with it more. Corn growers don't have the tall corn contest anymore. But we finally found the trick, and it's to get South American genetics, Central American, I think this is Guatemala from behind me, bringing it this far north, it gets taller than it would there, and so it gets pretty tall. But also kind of stretched me a little bit to understand why does it get taller in Central America versus what it would up here as we bring it farther north, which led to some better understanding of growing degree days and latitude where we place our corn, things like that, which really makes me absolutely amazed at what our Native Americans did with bringing corn from Central America, probably where it originated, clear north to the Canadian provinces. And they did all that before Europeans showed up, in 1492. So like I said, pretty amazing. So great depth in corn genetics. Some of the things I find interesting about our modern corn is, number one, 100 bushel, maybe 150 bushels more yield per acre under the same conditions. I did for many years had Reed's yellow dent in my trials here, where I actually do yield checks. I could get about 100, 105 maybe bushels per acre out of it under really good growing conditions. The last year I hit 105. My modern corn hybrid hit 300, so almost 200 bushels per acre better. Some of the other selections out of Reed's yellow dent I have in my plots behind me, they'll gain about 20 bushel over Reed's yellow dent, so that's what I have in here for yield checks. And then 2 or 3 years ago, I had a farmer in Wayne County, Worcester area, ask me about organic varieties, modern organic varieties. So I found a company out of Western New York. They're doing some plant breeding still, but all for organic, and they are varieties, so they're not crossed. They're not hybrids. I've got one of them in here that will hit 200 bushels per acre. Still not able to match the modern, the hybrids. We would not expect it to. But 200 bushel per acre out of a variety is pretty darn good, and way better than what we've seen from 100 years ago with Reed's yellow dent or something like that. But anyway, so this is one of the plots where we get truckers call the station as they drive by and they go, "What is that? What is that in the back?" And so from my standpoint, bringing attention to the corn plant in general, but to the crop in particular, is a really benefit for Ohio agriculture and for this farm as well. Not very likely to do some of this work on a private farm, but by having this research station, this facility, this site, really gives us an opportunity to do some things like this. We would not be able to do it.